Hey there, space explorers! Welcome to an exciting journey into the future of space travel. Today, we're diving into the fascinating world of ionic thrusters, a technology that's revolutionizing how we explore the cosmos. These amazing devices propel spacecraft through the vastness of space, enabling missions that were once thought impossible. But how do they work? Let's break it down step by step. Ionic thrusters use electricity to create thrust, a concept that's both simple and incredibly powerful. They ionize a propellant, which means they give it an electric charge, transforming neutral atoms into charged particles. These charged particles, called ions, are then accelerated out of the thruster at high speeds, creating a force that pushes the spacecraft forward. Think of it like this. Imagine blowing up a balloon and then letting it go. The air rushing out propels the balloon forward. In an ionic thruster, the ions act like the air, pushing the spacecraft through space with a continuous and efficient force. This method of propulsion is incredibly efficient, allowing spacecraft to travel farther and faster than ever before. Now, let's talk about a crucial element in our thruster: platinum. This precious metal plays a key role in the ionization process, acting as a catalyst to help generate the necessary electric charge. Platinum electrodes are used to ionize the propellant, ensuring a steady and reliable stream of ions for propulsion. With the help of platinum and advanced engineering, ionic thrusters are paving the way for the next generation of space exploration. So, the next time you think about space travel, remember the tiny ions and the incredible technology that makes it all possible. The future of space exploration is here, and it's electrifying. Platinum is a remarkable metal with a special ability. It can help us get oxygen from water. This process is called electrolysis. When electricity flows through water with a platinum catalyst, it splits the water molecules into hydrogen and oxygen. We can collect this oxygen and use it as propellant for our ionic thruster. This process is similar to how plants use sunlight to split water molecules during photosynthesis. Pretty neat, right? Now that we understand how to get our oxygen, let's move on to the main component of our thruster: copper-plated vanadium. Vanadium is a strong, lightweight metal, perfect for building spacecraft. We'll be using a special type of vanadium that's been coated with a thin layer of copper. This copper plating helps to conduct electricity more efficiently. Remember, we need electricity to ionize our propellant. Think of the copper plating like the wires in your house. Just like those wires carry electricity to power your lights and appliances, the copper plating on our vanadium will help to distribute electricity throughout the thruster. Now, let's get to the fun part: creating the honeycomb pattern. Why a honeycomb pattern, you ask? Well, this clever design increases the surface area of our thruster. This means we can ionize more propellant at once, creating more thrust. To make the honeycomb pattern, we'll use a special etching process. It's like drawing a design on the copper-plated vanadium, but instead of using a pen, we use a chemical solution. Imagine carving a beautiful honeycomb pattern into a pumpkin. We're doing something similar, but on a much smaller scale. With our honeycomb pattern ready, we can start assembling our ionic thruster. Section 5. Assembling our ionic thruster. First, we carefully place our honeycomb-patterned vanadium inside a cylindrical chamber. This chamber will hold our propellant, the oxygen we generated earlier. Next, we attach electrodes to the vanadium. These electrodes will deliver the electricity needed to ionize the oxygen. Think of building a model rocket. We're putting together different parts to create a complete system. Finally, we seal the chamber and connect it to a power source. Our ionic thruster is ready for testing. Section 6. The science behind the thrust. In this section, we delve into the fascinating world of plasma physics and how it powers our thrusters. When we apply electricity to the electrodes, something amazing happens. the electrical energy interacts with the gas molecules inside the chamber. The oxygen inside the chamber gets ionized, turning into a plasma. This ionization process is crucial for creating the conditions needed for thrust. This plasma is a superheated gas with an electric charge. The charged particles move rapidly, creating a dynamic environment. The honeycomb pattern comes into play here. Its unique structure is not just for show. It has a significant purpose. Its increased surface area allows us to create more plasma, which means more thrust. Remember the balloon example? The honeycomb design maximizes the interaction between the gas and the electric field. The more air we blow into the balloon, the faster it goes. This simple principle applies to our plasma thrusters as well. Similarly, the more plasma we create, the more powerful our thruster becomes. The efficiency of plasma generation directly impacts the thrust produced. But why is the honeycomb pattern so special? Let's find out. The honeycomb structure provides a larger surface area for ionization, enhancing the overall efficiency of the thruster. This design is inspired by nature, where honeycombs are known for their strength and efficiency. Section 7. Honeycomb Advantages. Efficiency amplified. The honeycomb pattern's magic lies in its ability to maximize surface area while using minimal material. This unique structure is found in nature, particularly in beehives, where bees have perfected the art of efficiency over millions of years. This means we can build a lightweight thruster that's still incredibly efficient. By mimicking this natural design, engineers can create components that are both strong and light, ideal for space travel. In space, every gram counts. The cost of sending materials into orbit is astronomical, so reducing weight without compromising strength is crucial. A lighter thruster requires less fuel to launch and can travel farther. This efficiency translates to significant cost savings and extended mission durations, allowing for more ambitious space exploration. The honeycomb pattern helps us achieve this goal. Its geometric design distributes stress evenly, making it incredibly resilient under pressure. Think of it like packing for a trip. You want to fit as much as possible into your suitcase without making it too heavy. The same principle applies to designing spacecraft components. You want to fit as much as possible into your suitcase without making it too heavy. The honeycomb structure allows for maximum efficiency in packing materials and components. The honeycomb pattern is like a super efficient packing method for our thruster. It ensures that every bit of space is utilized effectively, reducing waste and enhancing performance. Now, before you rush off to build your own ionic thruster, let's talk about safety. Working with advanced materials and designs requires strict adherence to safety protocols to prevent accidents and ensure the success of your project. Always wear appropriate safety gear, follow laboratory guidelines, and never take shortcuts. Remember, efficiency isn't just about performance. It's also about doing things the right way. With the right approach, the honeycomb pattern can revolutionize space travel, making missions more efficient and opening up new possibilities for exploration. Section 8. Safety first. Building an ionic thruster involves high voltages and potentially hazardous materials. It's essential to follow proper safety procedures and wear appropriate protective gear. Always work in a well-ventilated area and consult expert resources for guidance. Safety should always be your top priority. Remember, even the most exciting scientific endeavors require a cautious approach. Safety first, exploration second. Now, let's wrap things up. Section 9. Conclusion: your journey into space exploration. Congratulations! We've journeyed through the fascinating world of ionic thrusters, from the oxygen-making power of platinum to the efficiency of the honeycomb pattern. Building your own thruster may seem like a distant dream, but remember, every great scientific achievement started with curiosity and a thirst for knowledge. Keep exploring, Keep learning, and who knows, maybe one day you'll be designing the next generation of spacecraft. Keep those imaginations soaring and never stop reaching for the stars.